In this video, we'll review how to factor using greatest common factors. The greatest common factor is the biggest factor that goes into more than one number. So to begin, let's look at the first binomial. We have 6x squared minus 12x. Let's start by looking at the coefficients, the numbers in front. The biggest thing that will go into both 6 and 12 with division is 6. 6 divides into 6 once, and 6 divides into 12 twice. I notice that both of these also have x's. Let's look for which one has the smaller exponent. X to the first is smaller than x to the second, so I can take out the 6 and just an x. This means my greatest common factor is 6x. Now I'm going to divide 6x into both of these terms. 6 divides into 6 once. X squared divided by x is just x, so this leaves me just x. Now I can also think about this as distribution. 6x times x is what would give me 6x squared. Now the next piece is going to have a minus sign. 12 divided by 6 is 2, and x divided by x is 1. Basically, I'm factoring out the x. So this is going to leave me just minus 2. Now again, I can always check my work by distributing. If I distribute the 6x into the binomial, 6x times x is 6x squared, which is my first term, and 6x times negative 2 is my negative 12x. When you're done, it's always a good idea to look at what's still in the parentheses and make sure they have nothing in common. If it still has something in common, then you're not quite completely factored. In this case, x and negative 2 have nothing in common, so this problem is factored completely. Now looking at problem 2, I've got the numbers 8 and negative 20. I need to find something that will divide into both. Now while 2 does divide into both, it's not the biggest or the greatest common factor. In this case, 4 will divide into 8 and 20. I also have variables on both, so I look for the smaller exponent. I have just an x as opposed to an x squared. So putting it together, I can factor out both a 4 and an x. So my greatest common factor is 4x. Dividing 4x into both terms, 8 divided by 4 is 2, x squared divided by x is just an x, and I get 2x. I'll have a minus sign. 20 divided by 4 is 5, x divided by x is 1. So this leaves me minus 5. Closing the parentheses, I get this. Now looking at it, 2x and negative 5 have nothing more in common. This means this problem is completely factored. You can always again check your work by distributing. 4x times 2x is 8x squared, and 4x times negative 5 would make negative 20x. Now the last one's a bit tougher. Here, I've got the 15 and 20. The greatest common factor there would be 5. Both of them have a's, so I look for which one has the smaller exponent. A to the fourth is the smaller exponent. Putting those together, 5a to the fourth is my greatest common factor. Dividing each piece now by 5a4, I get 15 divided by 5 is 3, and a to the fifth divided by a to the fourth leaves just a. That means I have 3a. Negative 20 divided by 5 is negative 4, and a to the fourth divided by a to the fourth is 1, so that leaves me just the minus 4. And there's my factored form. It's 5a to the fourth times the quantity 3a minus 4. Now let's look at this problem. Here it's a trinomial. In order to do this problem, I would like to have it just to be a 1x squared. If I can get it to be a 1x squared, it's a much easier problem. I can just use my diamond problem approach and have it factored out real quick. But it's not a 1x squared. It's got a leading coefficient. But looking at it, the leading coefficient's 2. And I know that 2 will divide into 14 evenly and divide into 36 evenly. This means I can factor out the 2 and be left with something that is a 1x squared. So because it's not a 1x squared, I can make it that by dividing out the 2. 2 goes into 2 once, it leaves me a 1x squared. 2 goes into negative 14, negative 7 times, and negative 36 divided by 2 leaves me negative 18. Now it's a 1x squared. To do this, I can use my diamond problem approach and just look for numbers that multiply to be negative 18 and add to be negative 7. It must be negative 9 and positive 2. Negative 9 times 2 is negative 18, and negative 9 plus 2 is negative 7. When I rewrite it, I'm going to say it's 2 times the quantity, x minus 9, times the quantity x plus 2. If you took out a greatest common factor to start, don't forget to write it again. That 2 has to be there. Without it, if I was to multiply this out, there was no way that it would become a 2x squared. Now here's a few more problems. Go ahead and pause the video, work these out, and then resume the video to check your answers. I'll give you a moment. All right, hopefully you've had a chance to work these problems out. Looking at problem 1, I see it's a 3x squared. I'd like to make it a 1x squared by dividing 3. So let's check. 3 divides into 9 and into 6. 3 is the common factor. So we can factor that out to begin with. 3 goes into 3 once, 3 goes into 9 3 times, and 3 goes into 6 2 times. So I get 3 times the quantity x squared plus 3x plus 2. Doing my diamond problem, I would look for numbers that multiply to be 2 and add to be 3, which tells me it's going to be 3 times the quantity x plus 2 times the quantity x plus 1. Taking on problem number 2. It's a 2x squared, but I know that 2 will divide into both 8 and 42 evenly. So I can factor the 2 out. 2 divided by 2 is 1, so it leaves me at 1x squared. 8x divided by 2 is 4x, and negative 42 divided by 2 is negative 21. I now look for numbers that multiply to be negative 21 and add to be 4. That would have to be 7 and negative 3. So this will leave me 2 times the quantity x plus 7 times the quantity x minus 3. The third one's a little different. It's a trinomial, but it's not a 1x squared. Instead, it's a 1x cubed. I need to make this a 1x squared. And the way I can do that is I notice that all of these have a common factor of x. I can factor out the x to begin with. X cubed divided by x is x squared. Negative 5x squared divided by x is negative 5x. And negative 14x divided by x is just negative 14. Now I'm looking for numbers that multiply to be negative 14 and add to be negative 5. That would be negative 7 and positive 2. So this leaves me x times the quantity x minus 7 times the quantity x plus 2. All right, thank you for watching, and I hope this helped you understand how to factor using greatest common factors.